Hello everyone. In this video class, we are starting our next chapter, that is chapter 6, square and square roots. Look at this table. Here, in the first column, the side of a square in centimeters is given. In the second column, the area of the square in centimeters square is given. See, if the side of the square 1 centimeter, then the area will be 1 into 1, that is side into side. That is the formula of a square, area of a square. So 1 into 1, 1, that we can write as 1 square. Then if the side of the square is equal to 2, then the area is equal to 2 into 2, that is equal to 4, that we can write as a 2 square. If the side is 3, the area is 3 into 3, that is equal to 9, that we can write as 3 squared. 4, if the side is 4, then we can write the area is equal to 4 into 4, that is equal to 16, that we can write as 4 square. If the side is 5, we can write 5 into 5, that is equal to 25, which is 5 square. The same case in 8. So if the side is A, then we can write the area is equal to A into A, that is equal to A square. Numbers like 1, 4, 9, 16, 25 are known as square numbers. What is the special about the numbers 4, 9, 16, 25, 64 and other such numbers? Since 4 can be expressed as 2 into 2, that is 2 square. 9 can be expressed here. The 9 can be expressed as the product of the numbers with itself. So we say that such numbers like 1, 4, 9, 16, 25 are known as square numbers. Let me ask you a question. Is 32 a square number? We know that 5 square is equal to 25 and 6 square, which means 6 into 6, 36. If 32 is a square number, it must be the square of a natural number between 5 and 6. But there is no natural number between 5 and 6. Therefore, 32 is not a square number. Look at this table. From this table, we enlist the square numbers between 1 to 10, 1 to 100. Are there any natural square numbers up to 100 left out in this list? You will find that rest of the numbers are not square numbers. The numbers 1, 4, 9, 16 etc. are square numbers. These numbers are also called perfect squares. Let us try these questions. You can pause the video and try these. Find the perfect square numbers between 30 and 40. The second one, 50 and 60. So pause the video and find the answer. Next, let us understand the properties of square numbers. This table shows the square numbers from 1 to 20 and up to 25 is given, and the third square of 30, 35, 40, 45 and 50 also. Pause the video and study the numbers in this table. What are the ending digits? That is, digits in ones place. Ending digit, for example, if you take this 1225, the ending digit is 5. Here 256, the ending digit is 6. If you observe, all these numbers ends with 0, 1, 4, 5, 6 or 9 at its units place. Which are the numbers? If you observe, the square numbers ends with 0 or 1 or 4 or 5 or 6 or 9 at its units place. None of these ends with 2 or 3 or 7 or 8 at units place. Now let me ask you a question. Can we say that if a number ends in 0, 1, 4, 5, 6 or 9, then it must be a square number? Think about it. Can we say that if a number ends in 0, 1, 4, 5, 6 or 9, then it must be a square number? The answer is no. For that, pause the video and try these questions. The first question, can we say whether the following numbers are perfect squares? How do we know? By looking at the ending digits or the last units place, we can find out. Write 5 numbers which you can decide by looking at their ones digits that they are not square numbers. So you have to pick the square numbers, any 5 square numbers from it. The next question, write 5 numbers which you cannot decide just by looking at. If you can't decide, if you have a confusion by looking at the number, that numbers you can write in the second question in units place, whether they are square numbers or not. If you have any confusion, that numbers you can select for the second question. Let us consider square numbers ending in 1. Look at the first column, the square numbers is given. The second column, the number which gives the square number. If we observe that when we square these numbers, we get the square number which ends with the number 1. So we can say that if a number has 1 or 9 in the units place, then its square ends in 1. Let us consider the square numbers ending in 6. Look at the first column, the square is given, and the second column is the number which gives the square number. The 4 square is 16. If you observe all these numbers 4, 6, 14 and 16 ending with 6. So we can understand that when a square number ends in 6, the number whose square it is will have either 4 or 6, in its units place. Otherwise we can say that if a number ends with 4 or 6, its square ends in 6. Let me ask you a question. Can you find more such rules by observing the numbers and their squares? My dear children, pause the video and try these questions. First question, which one of these numbers would end with the digit 1? The second question, which of the following numbers would have digit 6 at its units place? Just find out. The third question, what will be the ones digit in the square of the following numbers? The question is, when we square the number, for example, when we square this number, we have to say what will come in the answer, that square number, which means when you square 1234 into 1234, when we multiply that two numbers, what will get in the units place? What we get, just 1234 into 1234, right? So when we multiply these numbers, 4 4s are 16, so we write 6 here. So the next row we write 0, so we know that in units place 6 will come. So using this, you should find out what are the answers, what are the units place values for the remaining numbers. My dear children, let us see some more interesting patterns on square numbers. First one, adding a triangular number. What is a triangular number? Numbers whose dot patterns can be arranged as triangles, like these numbers 1, 3, 6, 10 and 15 are the examples of triangular numbers. These numbers dots we can arrange as a triangle, as you are seeing. When we add two triangle numbers, two consecutive രണ്ട് triangle numbers, when we add these two numbers, we get a square. when we add 6 and 3, so when we arrange this end we get a square. See that 1 plus 3 is equal to 4, that is equal to 2 square. 3 plus 6 is equal to 9, that is equal to 9 is equal to 3 square. Then we can add these two numbers, 6 plus 10, we get a square. 6 plus 10 is equal to 16, that is equal to 4 square. The second pattern what we are going to learn is the numbers between square numbers. Between 1 square and 2 square, that is 1 square is 1 and 2 square is 4. There are two non-square numbers, that is 2 and 3 are there. See, if you see that, observe between 4 and 9, two consecutive square numbers. Between 4 and 9, we have 4 numbers, 5, 6, 7, 8. This non-square numbers are there. And between 9 and 15, 9 and 16, 16 is a square number. Between 9 and 16, we have 6 non-square numbers. അപ്പോൾ ഇതിൻ്റെ എത്ര നോൺ സ്ക്വയർ നമ്പേഴ്സ് ഉണ്ടാകുന്ന നോക്കുകയാണെങ്കിൽ 2, 4, 6, then next will be 8. So it will be like multiples of 2. ഇതിങ്ങനെ ആഡ് ചെയ്ത് പോയോണ്ടിരിക്കും. So how do you find it easily? If we are given any two square numbers, for example 9 and 15, what the 9 we are getting when we multiplying 3 square and 4 square. So between 3 square and 4 square. Okay, so between 3 square and 4 square, how many non-square numbers are there? How do we find? Between 3 square and 4 square. So how do you find? Means the smaller number, that is 3, that into 2, that we have 6. In between 2 and 3, between 2 square and 3 square, the smallest number is 2. So 2 into 2, like we get 4. So here the formula we can write is 2n. 2 into n. The n value is the smallest number among these. So where n is equal to natural number. Another pattern, third one, adding odd numbers. So first 1 is nothing but it is equal to 1 square. When we add odd numbers, 1 plus 2, the first and second odd number, that is equal to 4. It is 2 square. See that here 2 numbers we are adding 2 square. Next 3 consecutive odd numbers, 3 square. When we add 1 plus 3 plus 5, that is equal to 9, that is 3 square. Next first 4 numbers when we add, that is equal to 16, that is 4 square. First 5 numbers when we add, that is 25, that is 5 square. So let me ask you a question, that sum of first 36 odd numbers, how do you find? It's very easy. First 36 numbers, no? So we have to square that. 36 square, that will be the sum of all 36 odd numbers. The fourth pattern, the sum of consecutive natural numbers. So we can write these square numbers as a sum of two consecutive natural numbers. For example, 3 square is equal to 9. 9 we can write as 4 plus 5. If you see that, we can write these odd numbers in this format. 3 square we are doing. So this 4 and 5, if you notice that in between, so we can find like 3 square minus 1 by 2, and 3 square plus 1 by 2 is 5. 3 square is here, 3 square is 9, 9 minus 1 8, 8 by 2 4. അതേപോലെ 3 square is 9 plus 1 10, 10 by 2 എന്ന് പറഞ്ഞാൽ 5. അപ്പോൾ ഇനി പാറ്റേൺ നമുക്ക് കണ്ടുപിടിക്കാൻ പറ്റും. നെക്സ്റ്റ് 5 സ്ക്വയർ, ഓഡ് നമ്പേഴ്സാണ് ഈ ഒരു പാറ്റേൺ നമുക്ക് എഴുതാൻ പറ്റുന്നത്, ഓഡ് നമ്പേഴ്സിൻ്റെ സ്ക്വയർ. അപ്പോൾ 5 സ്ക്വയർ എന്ന് പറയുമ്പോൾ 25, അത് 12 പ്ലസ് 13 എഴുതാൻ പറ്റും. 7 സ്ക്വയർ ഇസ് 49, 24 പ്ലസ് 25. 9 സ്ക്വയർ ഇസ് 81, 40 പ്ലസ് 41. അത് തൊട്ടടുത്ത രണ്ട് നമ്പേഴ്സായിട്ട് എഴുതാൻ പറ്റും. അതൊരു രസകരമായ ഒരു പാറ്റേൺ ആണ്. 11 സ്ക്വയർ എന്ന് പറഞ്ഞാൽ ദാറ്റ് ഈസ് 121, 60 പ്ലസ് 61 എഴുതാൻ കഴിയും. 12 സ്ക്വയർ 225, 112 പ്ലസ് 113. അതിന് തൊട്ടടുത്ത രണ്ട് നമ്പേഴ്സിൻ്റെ പ്രോഡക്റ്റ്, സം ഓഫ് ടു കൺസിക്യൂട്ടീവ് നാഷണൽ നമ്പേഴ്സായിട്ട് ഓഡ് സ്ക്വയർ നമ്പേഴ്സിനെ നമുക്ക് എഴുതാൻ പറ്റും.